Welcome. Today we'll solve a complex integral using substitution. Let's look at our problem. We need to evaluate the integral of x squared times the square root of 1 minus x dx. The key to solving this integral is making a clever substitution. Let's let t equal the square root of 1 minus x. This means that x equals 1 minus t squared, and dx equals negative 2t dt. Now, let's transform our integral. When we substitute x equals 1 minus t squared, our integral becomes the integral of 1 minus t squared quantity squared times t times negative 2t dt. Now we can integrate term by term. The integral of t to the 6th is t to the 7th over 7. The integral of negative 2t to the 4th is negative 2/5 t to the 5th. And the integral of t squared is t cubed over 3. Let's simplify this expression. We can factor out negative 2 over 105, giving us 15t to the 7th minus 42t to the 5th plus 35t cubed. Now comes the crucial step. We need to substitute back to x. Remember that t equals square root of 1 minus x. After substitution and simplification, we get negative 1 over 51 times 1 minus x to the 3 halves times the quantity 15x squared plus 12x plus 8 plus c. Therefore, f of x equals 15x squared plus 12x plus 8. And the correct answer is option A.